today we will start with chapter 4. This is class 11 geography NCERT, the fundamentals for that. So it's about distribution of ocean and currents. Okay, let's read it through. In the previous chapter, you studied the interior of the Earth. You are already familiar with the world map. You know the continents cover 29% of the surface of the Earth, and the remainder is under oceanic covers. Position of continents and ocean bodies as we see them in the map have not been the same in the past. However, it is now a well accepted fact that oceans and continents will continue to enjoy their present positions in times to come. What? Moreover, it is now a well accepted fact that oceans and continents will not continue to enjoy their present in times to come. So they're saying it will be moving. Okay, if this is so, the question is where their positions, what were their positions in the past, why and how did they change? Even if the continents and oceans are changed and are changing the positions, you may wonder as to how the scientists know this. Have they determined the early positions? You'll find answers. Okay. So it starts with continental drift. I like the name, continental drift. Observe the shape of the coastal Atlantic Ocean. You will be surprised by the symmetry of the coastlines on either side of the ocean. No wonder how many signals are this consider possible of two Americas, Europe and Africa, to be once together. From the known records of the history of science, it was Abraham Ortelius. Okay, highlight on please. We have got a name here, Abraham Ortelius, a Dutch mapmaker who was supposed to as earlier in 1596 itself. Okay, then comes Antonio Pellegrini, who drew a map showing three continents together. However, it was Alfred Wegener. This guy comes even in that chemistry, coordination chemistry, Wegener's theory. Okay, a German meteorologist who put forth a promising argument in the form of the continental drift theory in 1912. This is again distribution of oceans, and according to Wagner, all the continents formed a single continent, mega oceans around the same. The supercontinent was in Pangaea, which meant all Earth. The mega ocean is called Panthalassa, meaning all water. He argued that around two. Which language is it? Pangaea, Panthalassa. Let's see which language it is. Pangaea language. Mm, Greek. Okay, it's from Greek. He argued that around 200 million years ago, the supercontinent Pangaea began to split. Pangaea first broke into two Laurasia and Gondwana and Laurasia, forming the northern southern subsequent Laurasia and Gondwana continued to break into a variety of evidence was offered in support of the continent. Okay, okay. Now we are going to see the evidences. One is the matching of continent jigsaw of it. The shorelines of Africa and South America facing each other have remarkable and unmistakable match. Oh, is it? We don't know, right? Uh, uh, what's that name? Yeah, continents. Continents images. Okay, let's open. This is, yeah, you can say fits somewhere. Hmm, and this also fits in a way. Okay. It's remarkable to note that may have produced a computer program to find the best fit of the Atlantic margin was when blurred. It proved to be quite perfect. The match was right at 1,000 rocks of same age across the ocean. The radiometric data chemicals developed in the recent period have facilitated correlating the rock formation between different. Okay, the belt of ancient rocks from Brazil and from Western Africa they matched. Okay, the earliest marine deposits along the coast of South America and Africa, the Jurassic Age. So the ocean did not exist prior to that period. Oh, this is nice. It's nice. Next is stillite. It's a sedimentary rock formed out of deposits of gas. Gondwana system of sediments from India is known to have its counterparts and six different landmasses of the southern hemisphere. The system has thick tillite. I don't know, for some reason I like south, that direction south and east. So even though India is in north, to feel like once we were in southern, the way system has thick tillite indicating extensive and prolonged glaciation. Mhm. The base has tillite counterparts of the succession found in Africa, Falk Islands, Madagascar, Antarctica, Australia, all are south. Overall, this continental security demonstrates these landmasses are remarkable. Glacial tillite provides an ambiguous evidence of paleoclimates, and also drifting of continents. Okay, placer deposits. India, six different lands in southern hemisphere. Okay, Falk Islands, Africa, Falk Islands, Madagascar, and Australia. The occurrence of rich placer deposits of gold in the Ghana Coast and the absolute absence of source of rock in the region is amazing. In fact, the gold-bearing veins are in Brazil, and it's obvious that the gold deposits of Ghana are derived from the Brazil plateau when the two continents lay side by side. Hmm. Okay, gold distribution of fossils when identical species of plants are adapted to living are found on either side of marine barriers. A problem arises regarding accounting for such distribution. Observation of lemurs occurred in India, Madagascar, and Africa led some to consider the continuous landmass Lemuria, linking these three landmasses. Okay, lemurs occur in India, Madagascar, led to Lemuria. Okay, Mesosaurus was a small reptile adapted to shallow brackish water. Skeletons of this are found only in two locations: southern Cape province of South Africa and Arabian formations of Brazil. The ocean in between them. Okay, fossils. Yeah, we had nice. So just a recap, it's like jigs of it. Okay, rocks are same are found. Okay, the tillite, the sedimentary rock which is formed out of glaciers. Similar rocks are found both. In a way, it's like example of this, right? Nothing new. Deposits of gold. It's also again the same. Distribution of fossils. Yeah, same types of animals we found. Okay, it's a different slightly. Magnus suggested that the movement responsible for drifting was caused by pole fleeing force and tidal force. Pole fleeing force relates to the rotation of the Earth. You are aware of the fact that the Earth is not perfect sphere; it has a bulge the equator. The bulge is due to the rotation of the Earth. The second force that was suggested by is the tidal force, attraction of Moon and the Sun that develops tides in oceanic matter. The Wagoner believed that these forces would become effective when applied over many million years. However, the most of us consider these forces totally inadequate. Good, even I feel the same. Post-drift studies. It is interesting to know that the continental most of the animals collect from the continent areas in the form of distribution of flora and fauna, deposits like delight, etc. Okay, a number of discoveries during the post-World War II added new information to particular information collected from the ocean floor mapping provided new dimensions for the study of. Okay, convectional current theory. Arthur Holmes in 1930s discussed the possibility of convection currents operating in the mantle portion. These currents are generated due to radioactive elements causing thermal differences in the mantle portion. Holmes argued that there exists a system of such currents in the entire mantle portion. This was an attempt to provide an explanation to the issue of force on the basis of which contemporary scientists conduct the. Okay, he's saying what was it the cause? One is the what is this? Convection currents, radioactive elements, thermal differences. Mm. Mapping of the ocean floor. Detailed research of the ocean configuration revealed that the ocean floor is not just a vast plain, but it's full of relief expeditions and map postal provided a detailed picture of the ocean relief and indicated the existence of submerged mountain ranges and as well as deep trenches. Most look at it closer to the continent margins. The mid-oceanic ridges found to be the most active in terms of rating of the rocks from the oceanic crust revealed that the fact that they are much younger than the continental areas. Okay, so the ones which are in the ocean are much younger. Rocks on either side of the crest of oceanic ridges have equidistant locations from the crest where found to have remarkable similarities both in terms of their constitutions and their age. Oceanic floor configuration. Man, how long is this? I've been speaking continuously. Lots of things. Hmm. Okay, let's come back. We'll see the ocean floor configuration. Now, in this section, we will shall note few things related to the ocean floor that helps us in understanding of the distribution of continents on ocean. We'll be studying the details of oceanic floor relief in chapter 13. The ocean floor. Okay, this is just the intro. Ocean floor may be segmented into three major divisions based on the depth of the as well as the forms of relief. These divisions are continental margins, deep sea basins, and mid-ocean ridges. What? Okay, three divisions: continental margins, deep sea basins, and mid-ocean ridges. Continental is from the transition between the continental and deep sea. They include continental shelf, continental slope, continental rise, deep ocean trenches. All these deep ocean are the areas which are considerable interest in so far as the distribution of ocean and continents is concerned. Abyssal plains, these are extensive plains that lie between the constant and ridges. The abyssal plains are the areas where the continental sediments that move beyond the margins get Okay, we get a flat area. Then there's mid-ocean ridges. This forms an intercontinental mountain system. It is the largest mountain system on the surface of the through submerged under the ocean waters. A central rift system at the crest, a fractionated plateau, and a flying zone all along its side. The rift system at the crest is a zone of intense volcanic activity. Okay, next is distribution of earthquakes and volcanoes. Figure 4.2, where is that? Okay, I see. Famous Ring of Fire. We have this around Pacific Ocean, Japan, Korea, China, South China Sea, Philippines, and that Indonesia group, Australia, New Zealand, some islands. Okay, so line of dots in the central parts of the Atlantic Ocean almost parallel to the coastlines. Okay, central part of Atlantic Ocean. Yep, here something is going on. It further extends into the Indian Ocean. It bifurcates. Yeah, it's going into the Indian Ocean as well. It bifurcates. Yeah, it's bifurcating here. It's going towards the branch maybe. Yeah, the one is similar to Myanmar. We'll notice that these line of dots coincide with the mid-ocean ridges. The shade belt showing another area of concentration. Foci of earthquake in the areas of mid-ocean ridges are at shallow depths, whereas along the Alpine Himalayan as well as the rim of Pacific, the earthquakes are deep-seated ones. The shallowest shows, the rim of the Pacific is called rim of fire due to the existence of active volcanoes in the area. Okay. Concept of sleeve floor spreading. Positive studies provided consistent information that was not available at the time of Wagner put forth this concept, particularly the mapping of some. It was realized that all along the mid-ocean ridges volcanoes are common and they bring huge amounts of lava to the surface. Rock sequestrations on either side of the crest show remarkable similarities in times. Okay, okay, rocks closer to the have normal polarity and youngest. Okay, the age of the rocks increases as the one moves away from the crest. Oceanic crust rocks are much younger than the continental rocks. The age of rocks in the oceanic crust is over more than 200 million. Some of the continental rocks are more than 3,200 million years, 3 billion years. Sediments on the ocean floor are unexpectedly very thin. Scientists were expecting the oceanic floors as old as deep trenches of deep seated earthquake. Okay, these facts and details of man, so many facts. This automation, this proposal, his hypothesis. Hess, this guy is so famous. He keeps coming with some or the other. Hess law, which are known as the seafloor spreading. Which guy proposed seafloor spreading? Hess. He has argued that the constant eruption at the crest of the ocean caused the rupture of the ocean and the new wedges into it, pushing the oceanic crust on either side. The ocean floor thus spreads. The younger age of the ocean crust, as well as the fact that the spreading one does not cause the shrinking of the other. So now he further maintained the basic concept has been depicted in figure 4.3. Okay, this is spreading here. Basically, this keeps getting added. This gets piled upon, and because of the piled upon, the lava flows this side, so it spreads. Okay. Since the plate tectonics, since the advent of the concept, the interesting problem of the distribution of ocean was revived. It was in 1967. McKinsey and Parker and also Morgan independent collective LB then came out with another concept called plate tectonics, a tectonic plate, also called lithospheric plate. It's a massive irregular shaped slab of solid rock. Tectonic. How many plates are there? Ah, okay. I have again completed. Let's hold on. Let's complete this. A tectonic plate, also called lithospheric plate. It's a massive regular shape, generally composed of both continental and oceanic lithosphere. The plate moves horizontally over the asthenosphere as a rigid units. Yeah, what is asthenosphere? Yeah, I think it's something between the top portion of mantle or something, or the forgot. What do you remember, bro? Then asthenosphere, upper mantle. Yeah, right. Atmosphere. The lithosphere includes the crust and top mantle with its thickness range varying. Plate may be referred to as a continental plate or oceanic plate depending on which to occupy a larger portion of the plate. Okay, if it's more that Pacific plate is larger than oceanic plate, whereas the Eurasian plate may be called a continental plate. Theory of plate tectonics proposes that the Earth's lithosphere is divided into seven major and some minor plates. Young fold mountains, etc., etc., are found on these major plates. The major plates are as follows. Okay, the Antarctica and the surrounding ocean plate, North American with the Western Atlantic flows separating from the South American plate, South American, Pacific, India, Australia, New Zealand plate. Why is India, Australia, New Zealand together? Very weird. What are they separating? Young fold mountain trenches or faults around these major plates. Some unevenness. Africa with the Eastern Atlantic floor plate. Eastern Atlantic. Okay, this is right. Eurasian adjacent some important minor plates: a Cocos plate, Nazca plate, Arabian plate, Philippine plate. Okay, Caroline plate, Fuji plate. Go through the history. It's not the continent that moves, as believed by back then. Continents are part of plate and which moves on the plate. Okay, moreover, it may be noted that all the plates, without exception, have moved in the geological past and shall continue to move in the future as well. Ireland, thought of the all the continent initially as a supercontinent. The later discoveries reveal that the continental masses resting on the plates have been wandering all through the geology and Pangaea as a result of converging of different continental masses that were parts of one of other plates. Using the paleomagnetic data have determined the positions held by each of the present continents in different geological periods. Position of Indian subcontinent, peninsular India is traced with the help of rocks analyzed from Nagpur area. There are three types of plate boundaries. Okay, divergent. There are three types of land: divergent, convergent, and transform. When new crust is generated as the plates pull away from each other, the sites where the plates movements are called spreading sites. The best known example of divergent boundaries is Midland and the American plates. The crust is destroyed as one plate dived into another. The location where sinking of the plate occurs is called subduction zone. There are three ways in which convergence can occur. These are between an ocean and a continental, between two oceanic, and between two continental. Yeah, even the same for divergent, right? No, where okay, next is transform models. When the crust is neither produced nor destroyed as the plates slide horizontal past each other, transform falls up against a separation generally perpendicular to the mid of the ocean, the entire coast. Okay. Rate of plate movement. The strips of normal reverse magnetic field that parallel the help scientists determine the rates of reverse magnetic field. These rates are varied considerably. Arctic ridge has the slowest rate. East Pacific is near Easter Island. In the South Pacific, about is the fastest rate. What is the for the force for that? At the time this I think must be believed that the earth is solid motionless. However, its concepts of free flow splitting in the infinite theory have emphasized the both the surface of the other interior are not static motion. They are dynamic. That plates move is now well accepted. The mobile rock beneath of the rigid plate is believed to be moving in circular manner. The heated material rises to the surface, spreads and begins to cool, and going into the vapor depths. The cycle is repeated over and over to generate what scientists call a convection cell or convection cell or convective flow. Heat within the earth comes from two main sources: radioactive decay and residual heat. Let's first consider this idea, and which later influenced Harry Hess thinking about seafloor spreading, this slow movement of hot soft mantle that lies below the rigid plates. Okay. Okay, now we have local Indian Wala plate movement. Indian plate, early India, just stuck to Africa. It's an Australian portions. Subduction zone along the Himalayan forms the northern plate boundary in the form of continental convergence. Yeah, in the east it extends through Rakinomia mountains of Myanmar towards the island arc along the Java Trench. Eastern margins is a spreading site lying to the east of Australia in the form of oceanic ridge in the southwest Pacific. The western margin follows the Kirthar mountain in Pakistan. It further extends along the Makarana coast and joins the spreading site of the Red Sea Rift southeast along the Chagos archipelago. The boundary between India and the Antarctic plate is also marked by oceanic ridge. Running by India was a large island situated off the Australian coast from the vast ocean. The Tethys Sea separated from the Asian continent till about 225 million years. India is supposed to have started her northward journey about by her. Okay. 200 million years ago, at the time when Pangaea broke, India collided with Asia about 40-50 million, causing rapid uphill from Himalayas. The position of India since about the shown figure. It's also shows the position of Indian subcontinent Eurasian plate. About 100 million years ago, the present subcontinent was located as a south as major plates were separated by Tethys Tibetan block was closer to the Asiatic landmass of Indian plate. The major event that occurred was the outpouring of lava and formation of Deccan traps. Deccan traps. This started somewhere around 16 and continued for long. Note that the subcontinent was still close to the equator from 40 minutes ago, and thereafter the sea event. Plus, scientists believe that the process is still continuing and height is rising event rate. Okay. Yeah, we are done. Okay, let's see the exercise. Who amongst the following was the first to consider the possibility of Europe, Africa, America have been located side by side? Yeah, it's Wagner. Hey, uh, this is not good. Let me take eraser. I think polar fleeing force relates to polar fleeing. I think rotation. So is not a minor plate. Antarctica is not a minor plate. So the following facts are not considered by those while discussing the concept of sea floor spreading. Volcanic along the mid-oceanic ridges. Yes, volcanic stripes on northern reverse magnetic field observed in rocks. Yep, distribution of fossils. Sea floor. Age of rocks. I think fossils. Different continents. Why would we talk about continents in sea? Which of the following is the type of plate boundary of the Indian plate along the Himalayan mountains? Himalayan is convergence. Continent, right? Because we are hitting Asia, India. I think these are good enough. Okay, we are done for today. Bye bye.